Let us now get started with installing and using Ngspice. Let me open a command window, a terminal, and install Ngspice first. Sudo dnf install Ngspice. I am using Fedora Linux distribution. My students have installed it on other Linux distributions too. So you will get the Ngspice package from the repository like this. Install it on your machine. Along with Ngspice, it is good to install also TCL Spice. So I will do just that. Install TCL Spice also. So this will search the repository, download the package, and then install it. Likewise, in other distributions also, use the appropriate downloading tool to install Ngspice and TCL Spice. So we have installed them and we are now ready to go. This, along with a text editor, will get you started immediately. Let us understand the process of simulation in Ngspice by means of a simple attenuator circuit. So let us take a DC source, and to the DC source we will connect two resistances in series in this fashion. Mark the common reference or the common ground of the circuit with respect to which all other node voltages are measured, and indicate that node name, the common or the reference node name, as 0. We will call this node as A and we'll call this node as B. Let's say the source is V1, and let us say we will do the simulation for 100 volts, and this is R1 and R2. We will vary the values of the resistances R1 and R2 in the simulation. So this, let us see how we will put it into a circuit file and call an Ngspice and execute the simulation. Let us now consider this simple attenuator circuit and see how we will simulate it in Ngspice. First of all, let me create a folder, a blank folder. I'm calling this as one work. It's a workspace where I will place the necessary files. So this is a blank folder now. I have opened the gedit text editor, a blank file. So let me save it into this workspace, one work. Let me go in there and give it a name. So example 01 and the extension .cir. So you see here example 01.cir. CIR stands for circuit. So it appears here in the directory folder too. So in this frame, I will have the terminal window, I will have this gedit text editor, and I am having the circuit here. Now let us start writing the code for this circuit in the .cir file. Before starting to write the .cir file for Spice simulation, download the manual of Ngspice and read through it. The first line is always a comment line. It's a title line. You write the title, let's say a simple attenuator circuit. The star here, the line where the star is the first character, anything followed by the star is a comment line. Next, I'm having again a star. This line is a comment line. I'm saying netlist. Let us write the netlist for the circuit. So here we'll start by the source V1. V1 is between the nodes A and the 0 or the reference node. So let us write that down. V1 between A and 0, the value is 100 volts. And then R1 is between node A and B. R1 is between node A and node B. Value 10 ohms, let us say. And then R2 is between node B and 0. B and 0, we will give it also a value of 10 ohms. And that's it. We have now the netlist for this circuit. We have the nodes, we have the symbol names, and we also have the values for each of the component. Now you save the circuit. So example 01.cir is now saved in one work directory, one work folder. So we come to the command window. There, let us move into the work folder. So I'll just do a cd work folder. When you do an ls, you see the directory. There is the example01.cir. So type in ngspice example01.cir. You now get into the Ngspice environment. I'll do a Control L to clear the screen. So you are in the Ngspice environment. If you want to see what is the netlist that is there, that is loaded, you can type the command Ngspice command listing. It will list the circuit that is there in the workspace, the same circuit. Now you want to do some operation on this. Let us say we want to check the bias points, that is OP, operating point analysis. So when you do that, it will run the simulation and perform the bias point operations. Now you want to see the voltages. So let us print the node voltage VA. Node voltage VA is the voltage at this node A with respect to ground 0. We also would like to see the voltage at B with respect to 0. So you can type in VB. Of course, this is a simple circuit. We know that node at voltage A is 100 volts and at VB is 50 volts because it is a divide by 2 attenuator. So this is your first circuit where you have done a bias point analysis using the OP or the operating point command, and you have got the results here using the print commands. Now let me make a change in the circuit values. Instead of 100 volts, let me put it as 60 volts, and let us say R1 is 20 ohms. Let me save this. Now this this circuit with new parameter values need to be taken into the Ngspice environment. So the command that I will use is source ex01.cir, which means I am now reloading the source. So source would have reloaded. I can do the listing and check whether the parameter values have changed. Now you see that in the Ngspice workspace it is 60 volts instead of 100 volts, 20 ohms for R1 and 10 ohms for R2 as before. Also remember that Ngspice is case insensitive. It will not distinguish uppercase and lowercase. Keep that in mind. Now you run operating point analysis and print VA and VB, and you will see that VA 60 volts, VB 20 volts because of the values that we have given here. You could also see the current through the source, print current through V1. So normally the current through a source, if the current is coming out of the positive of the source, then it is negative. If the current is going into the positive of the source, then it is positive. So you will see that you have the current going into the source is minus 2 amps, which means that the current is coming out of the source, which is so in this case. Sometimes it becomes repetitive and cumbersome to write and type the control commands in the Ngspice workspace. It may be a good practice to place it in the .car file itself. So what we will do next here is place the control commands in the .car file itself within the control command begin and control command end statements. So in between you can place the control commands. I am placing OP there with the operating point analysis. I can also place the print statement, print VA, print VB, print VAB, print the current through the source like this. Now you save this and in the workspace run Ngspice. Ngspice example01.car. It will also execute the control commands. In this case, it is the operating point or the bias point analysis, and then prints out VA, VB, VA between A and B nodes and the current through the source V1. Sometimes if you want to look at all the vectors, all the parameters, all the node voltages and the branch currents, you can just say print all. You can see that, save. I'll just exit Ngspice and again call Ngspice example01.car. So you see that it prints all the nodes, A node, B node voltage, 60 volts, 20 volts, and the branch current, V1 branch current of this source is minus 2 amps as it is flowing out of the positive terminal. So in this way, you can place the Ngspice control commands within this dot control and dot .nc control structure along with the netlist and use it as an integrated .cir file.